Okay, so today we get to watch this crazy guy jump off a bridge. And watch the video a couple times and use your phone to time it. And after you've figured out exactly when you want to start the video and stop the video, when he leaves the bridge and when he lands in the water, then you need to do 5 times. So go ahead, pause this video, click on the bridge jump video link, and watch the video several times, and then create 5 times, and then come back. Okay, you're back. So let's say that my first time was 45 seconds. Then I use this formula. This is the acceleration due to, like 1.4 seconds. Sorry. So 16.078 times 1.4 squared is 31 feet. And then let's say that my next one was 1.8. That would give me 52 feet. And I finish, let's say I end up with 45, 47, and 44. Okay? So I need to go through and see how many of my heights land in these intervals. So I have one here, and then I have, and this is left endpoint convention, which means 40 is a yes, 45 goes in the other side. So I have 1 in there, I have 2 in there, and I have 1 in there. Okay. Now, I sent you an email it's a Google form for the bridge jump video. So go into your email, enter all 5 of your heights, and submit it. And then when we come back, I'll show you what that looks like. Okay, now that you have entered all of your heights, here they are. And you don't need to write them all down. But look at your paper and see how many of these heights land in each of the class intervals. So let me go back to this page right here. So we need to count how many are less than 30. So I go in here, less than 30, there's only 1. So right here I would put 1. And then I go back and I look, how many are between 30 and 35? Only 1. So I go back here and then I write 1. And then how many are between 35 and 40? So that would be 1, 2, 3, 4, 5, 6, 7, 8. So I go back here, then I put 8. Now, I do the same thing with the rest of those. Oh, I'm missing one. Oh, oops. This one is supposed to say h is greater than or equal to 60. That's weird. I'll have to fix that later. Okay, and so take all of your class intervals and all of those, the number in each class interval, and then create a histogram, which should look like my histogram over here. Did everybody get a histogram that looks like that? So, is this normally distributed? Yeah, that looks like a normal curve. Might have a bit of a skew to the right, but it really is quite close. So if I were to superimpose the normal curve on top of it, that's pretty good. You can see the right side sticks out a little bit, but it's close enough, so we're going to go ahead and use it. Okay, and I noted the average is 45 and the SD is 6.25. Okay, so at the bottom of the first page it says, would you say it's normally distributed? Yes. What would you guess is the actual height of the bridge? Okay, our best guess would be 45.8. Are we sure? No. Okay. So, what does the standard deviation of 6.25 mean? What does this tell us? What does the standard deviation mean? Well, what does this? How do we get the standard deviation? We take every take every height, figure out how far it is away from the average. We take all those numbers and we square them and we add them up and take the average, and then we take the square root. So the standard deviation is the average distance from the average. So all of your scores, on average, are 6.25 feet away from 45.8. Okay, and we talked a lot about the average in the past and what it truly means. I read an article last night that was another way to deal with the average. In our coronavirus time, this article I read said that over the last couple months, somebody has a positive test for the coronavirus every 2 seconds. And it said every 2 minutes, somebody dies from the coronavirus in the United States. Okay? That's another way to describe the average. Are 2 people really getting tested positive every 2 seconds? No, the labs only run during the day, and sometimes they don't run on the weekends, or I guess they slow down on the weekends. If you look at the coronavirus case numbers, so early in the week they're kind of low, and then they peak on Friday and Saturday, and then they drop down on Sunday. Why would they do that? Does it mean people are out on the weekend and that's when they get the coronavirus and 7 days later they get tested? No. Why are there peaks? Because people don't go to the doctor on Saturday and Sunday, right? You're more likely to go to the doctor on a Monday than you are on a Saturday or Sunday, and if it takes 3 or 4 days to get your test back, that would explain why Thursday, Friday, Saturday have the highest numbers. Okay? So, one way to talk about the average is if we were to take away everybody's Skittles and then redistribute them evenly, the average is how many Skittles each person would get. But another way is like this. We average a positive test every 2 seconds. Now that's not true, right? We probably don't have very many positive tests at 8 in the morning, right? At 4 a.m., nobody's doing testing, I hope. So there are probably a lot of positive tests at 3 o'clock, 4 o'clock, 5 o'clock, right? But when we average those out, all the tests would be spread out every 2 seconds. Similarly with the deaths, it's not, 2 minutes in, somebody just died. 4 minutes in, another person died. That's not how it works. If we look at all of the deaths and we divide it by the total number of months, we end up with every 2 minutes on average, somebody dies of the coronavirus in the United States. Okay. So, looking at this, would it be fair? Well, do we think that 28.8 is a possible height? No, I don't think so. I jumped off the bridge. I mean, that crazy guy jumped off the bridge. Had to have been higher than 28 feet. Okay, similarly, we had 2 that were above 61. Do we think the bridge is that high? I pretend it's that high, but it probably isn't. Should we just throw those numbers away? No. Just like when people put themselves in their own groups to be studied, we get rid of randomness. And then when we as researchers decide, you don't count, if we don't have a good reason for that, then we shouldn't do it. Okay? If we find out that Zane's phone was in fact broken and that's the reason it was low, then we can toss it out. Right? Or maybe Zane's not smart enough to run a stopwatch. Then we can throw it out. But if we don't have a good reason to get rid of it, usually don't get rid of it. Now, sometimes we do, sometimes we don't. But the textbook we're reading suggests that you should not. Okay. So now, turn the page. everybody needs to find their own height. Oh, shoot, I deleted my numbers. So let's say that I take my numbers and I find out that my height average is 47.3 feet. Oops. Feet. Okay? So, write down your average and then go around the class and collect the average of 9 other people. That way, everybody will end up with a list of 10 averages, and hopefully nobody's list will be identical to anybody else's. Okay? Do that. And then come back. All right. Now that you're back, let's look here. So my average was 47.3. And what was your average? 54.28. Okay, this is boring. I'm done with that. Okay, so I keep doing that. And then how do these averages compare to my average? Well, they're pretty close. That one's quite low. That's okay. We don't expect a lot out of you. Okay. So now, can I take the average of the averages? Are we allowed to average averages? Yes, as long as every person had the same number of measurements. If I had 8 measurements and you had 5 and we averaged them, it's not going to work because you would need a weighted average. So I'm going to take the average of all 10 of those, and let's say that my average comes out to be 43.6. Okay? Now, compare your average of the averages to other people's averages. Okay, are they the same? No. They're going to be off by a little bit. So here's what we're doing. Okay? There is some line that represents the true height. And let's say that line is like 46 feet. Okay? Well, some people are going to be left of that and some people are going to be right of that. And you'll also have a standard deviation. So over here, oh, dang it. Down here, the class average was 45.8 with a standard deviation of 6.25, which means 68% of these numbers are within 6.25 standard deviations. Okay? And the more times we measure, the more reliable our answer is going to be. If we only measured 4 times, then we're not going to have a very representative curve, and we might not end up with the true average. So that's our best guess. But you can see that if you talk to different people, that average changes. So we're not quite sure what the true number is. Okay, what sort of biases might exist in these measurements? Okay. Yeah, there are all sorts of measurement errors we could make, right? And even your phone app might be a problem, right? It's very possible that the first touch lags a little bit and it turns the clock on, and then if the turn off does not lag, then your time will end up being slightly shorter than it's supposed to be. Or the opposite could happen. If your phone app is really good at turning on but not as good at turning off, then your measurement might be too long. How many of you anticipated the jump and you tried to time your finger right when the jump happened? How many of you, when the jump happened, you tried to push the button? Do you see the difference? If you anticipate it, then you're going to click a little bit early than just reacting to it. Does that make sense? Did you turn the stopwatch off at the sound or at the physical hitting the water? Because that's going to be different, right? If you use the sound, it takes time for the sound to go from the speaker to you. And then it would take time for you to touch the button. So there are lots of measurement errors that could happen in this case. Can we safely assume that our final average of 45.8 is the correct height of the bridge? Do we think this is exactly correct? No. We would expect it to be close. We practiced a lot. We had a lot of different people doing it. Some people were probably too fast and some people were probably too slow, but on the average, it should be pretty close. So what could we do to find a more accurate measurement of the height of the bridge? Okay, more people. That's always good. Add more people. There actually is a specific thing in statistics that you can have too many people. Where too many people actually is a bad thing, but this isn't it. What else can we do? So, if we made a mistake, whose fault is it? Right? If there are mistakes, who can we blame? Yourselves. So what if we remove you from the measurement? How could we do that? How could we remove human error? Technology, computers, what would you do? You would get a video software that has a timer on it and go in slow motion. And then you can get the exact time that the jump started and the exact time that the jump ended. And then that would be you'd only need one measurement, right? If you went slow enough. So I did that, and I believe it was like 46 feet. So you guys did a pretty good job. I'll have to double check that, but I think 46 is the answer. So, whoa. This is your first time succeeding in your whole life. All right. Thanks for playing.